Hello, this is CodePal, and for today's video I will be teaching you about functions. I'm going to start with creating a file called functions.py in code. Once I do that, I will teach you about functions. Functions are a block of code that runs when it is called. In Python, when writing functions, you can specify a return statement within your function that will return a particular value. We have actually been using functions since my first video. Can you guess the function that we have been using? The answer to the question that I just asked is the print function. We have been using this inbuilt function to print various input strings since the first video. I can actually go ahead and access the documentation related to this function within Python. In the documentation, I can find how the print function is defined. Generally speaking, a function has three parts of a function. I'm going to use an example to explain the different parts of a function. I'm going to explain this using the print function. If I want to print hello world, what are the different components that are being used? The three parts of a function are name, what is the name of the function? Input, what is the input value of the function? And output, what is the result or answer from a function? So now I'm going to use the print function and explain each of these three components. The name for my print function is print. The input is the Python object, which in this case is hello world, and the output is none, as the print function does not return anything. Now I'm going to name this function equal to output of print, and I will then change the input of the print function to output of print. When I go to the terminal window and I run this, I get none, which is what I expected. User-defined function, add. For this particular section, I'll be exploring user-defined functions, and more specifically how a user can provide two values and which will then get added. So I'm going to be writing a function where I add two numbers. So I'll start with defining my function. I'll use the word def, D-E-F, which will be used to define my function, and I'm naming my function add. So my function add is going to take two input parameters, and those are number_1 and number_2. After I have done that, I'm going to end it with a colon, and within that I'm going to be explaining the logic or the body of my function, and that is what exactly is this function do. So what this function does is it's going to output it's going to be adding two numbers, number 1 and then number 2, and I'll equate that to a variable that I'm going to call res, which is my output. So what I'm going to do following that is I will be printing res. And so this is my total function. I'm defining my function, and then within that I have my body explained. When I want to call on this function, all I have to do is call the name of the function add and provide the two user parameters, so 12 and 8 for my case. When I add those two values, I get 20. And when I head to terminal and I run this path, that's exactly the value I get. So my user defined two values, 12 and 8, and that's the right. User-defined function subtract. I will define the function subtract where my input values are going to be number 1 and number 2, and I'll write my body where res will equal to number 1 minus number 2. I will return res. Unlike my previous example with addition, I'm not calling the print function in my body. Instead, I'll end my body with returning res. I will call the inbuilt print function, which will then call the subtract function, and the input values for that function will be 12 and 8. And when I run this, I should get the value of 4 printed as my output. I first call the print function, within which I call the subtract function with two user values, 12 and 8. When I run this, I get the value of 4, which is exactly what I expected. So far, I've introduced functions that do addition or subtraction. Now I want to write a function that will do addition over a range of values. I will start with defining my function called range sum function with two input values, x and y. I will also set res equal to 0. Then I will utilize for loops, where I'll use the inbuilt range function with input values of x and y plus 1. Within my for loop, I will then add res to I. This is also denoted by the plus equals operation. The range function returns a sequence of numbers starting from x in increments of 1 and stops before y plus 1. This is why y plus 1 is used instead of y, so that y values is included in the addition. So for the first iteration of the loop, I will get res plus I, which will then become my value for res for my second iteration of the for loop. By doing so, I'm adding values over the range. When I call the range sum function within the print function for input values of, let's say 12, 15, I'll get 54. 12 plus 13 plus 14 plus 15 should give me 54. I just want to bring to your notice that I made a typo in my notes. It should not be 41, it should be 54. And I have corrected that now. And I can also do this by using the add function. So I can say that res is equal to add, and I have two input parameters, res and I. And what I would do with this is I would get the exact same answer as I get here, the 54. What's unique about this is that we have a function inside a function. So it's nested. We have a function, which is a range sum function, and within that we have another function that we are using, which is the add function. Function and recursion. Now I will use function and recursion. A recursive function is a special type of function that calls upon itself when executing. An excellent example of this would be the Fibonacci formula. The Fibonacci number is the sequence of numbers where the value of the current number is the addition of the last two values combined. So if I take my first value to be x0 and I equate that to 0 and I define my x1 value to be 1, then my x2 value would be 1, x3 value would be 2, x4 value would be 3, x5 value would be 5, x6 value would be 8, and so forth. I've already written out my Fibonacci iterative function, and I'm going to spend some time and walk you through it. So the first thing I'm going to do is I'm going to define my Fibonacci iterative function with input value of n. I'm going to introduce two values, my first value for my sequence and my second value. So the first value, x of n of 2, is equal to 0, and my second value, x of n of 1, is equal to 1. Then I'm going to define if my value of n is 0, n is 1, and in the case it's greater than 0 and 1. It's not the first value, it's not the second value, what to do. I'm going to be using if statements for that. So if my value of n is equal to 0, I'm going to be returning x of n of 2. If my value of n is equal to 1, I'm going to be returning x of n of 1. Else, if my value of n is neither 1 nor 0, what should I do? I'm going to be using for loops, where I'm going to set my range equal to n minus 1. I'm going to be using that to calculate my new value of n. My new value of n, which is x of n, is equal to x of n of 1 plus x of n of 2. As I explained earlier in this video, for my Fibonacci iterative, my value would always be the sum of my last two values, and that's exactly what I do here. And once I do that, I'm able to find the value of my last two values. What I need to do is I need to move my n value over 1. So I need to shift the position of n. And how I can do that is I can say that x of n of 2 is equal to x of n of 1, and x of n of 1 is equal to x of n. By doing so, I'm moving by one position. I'm moving my n by one position. And then I'm going to follow that with return. I'm going to be returning my x of n, and by doing so, I'm able to obtain my Fibonacci iterative given a value of n. And the last thing I want to do is I want to print the Fibonacci iterative for 3 different values. I want to do it for n equals 0, n equals 1, and n equals 12. What I'm going to do now is I'm going to introduce a similar concept, which is the Fibonacci recursive. And what I'm going to do here is I'm going to start with defining my function, which I'm naming as recursive, the Fibonacci recursive with input of n. And what I'm going to do is define my if statement, similar to how I did in my previous example with the Fibonacci iterative. So if my value of n is 0, I'm going to return 0 or n. Else if my value of n is 1, then I'm going to return 1 or n again. And for my third case, when my n is not 0 and my n is not 1, what do I do? And this is where my logic diverges from my Fibonacci iterative. What I'm going to do here is I'm going to define res using the Fibonacci recursive function. What I do here is I'm going to say that Fibonacci recursive of n minus 1 plus Fibonacci recursive of n minus 2 is equal to res. And now we'll be returning res. What's important to note here is that a recursive function is used to calculate the nth term of a sequence. And what I do here is I use for loops to iterate and calculate each term recursively. It's also important to note that in recursive we use functions, and in iterative we tend to be faster, but we're not using functions. We primarily rely on for loops to be able to develop our logic. Now I'm going to print my Fibonacci recursive and my Fibonacci iterative for values, 0th value for first value and the 12th value. And what I find is that I get values of 0, 1, and 144 respectively in both cases, and that's exactly the answer I should be getting. For the 0th Fibonacci recursive, the value should be 0. For the first, it should be 1, and for the 12th, it should be 144. Thank you so much for watching. Please like and subscribe to my channel. This is CodePal signing out.